Dr. Riley here with our final topic in Unit 1 and 2 here, Chapters 1 and 2 in the book, kind of putting it all together, representing relations in 4 different ways: words, equations, tables, and graphs. There's a little real world example here on page 37 is fireworks. Okay, so every 1 inch increases the fireworks height by about 100 feet. You can represent that relationship in 4 different ways. That's the words representation. You could also do it as an equation, a table, or a graph. Okay, so you've already seen that we can represent relations as sets of ordered pairs, right? So just giving the x and y values, the 2 numbers that go together, okay? You can write a rule, okay, also known as a function rule, which we will cover functions later on in chapter 9, but you might hear me refer to it as a function rule just because that's my 8th grade math history. So that I use that all the time. It's also an equation, right? A rule is an equation that has the 2 variables in it, okay? And you can also do a table, and you can also make a graph, right? So the first one here is they're playing, of course, this popular game, What's My Rule? What's my rule? Double a number, then add 3. So there's words that you need to translate to an equation, okay? So that's what they ask you to do. Make a table with 4 different values in the domain, and then write an expression, which you can write that as an expression or an equation, depending on whether you put the y equals in there or not. And then state the domain and the range. Okay, so the steps here: make a table showing the x coordinates. Now, the x coordinates that you pick here, the domain values, you can pick them yourself if they're not picked already for you. If they don't tell you what values to use in the domain, then you choose them yourself. We'll talk about that in a second. Then you do your rule. Double a number, then add 3 means to multiply that input number times 2 and then add 3. Okay, so there's your rule. And then that will give you the output. So your input value goes into the rule and you get your output. Okay, so 2 times 1 plus 3, use the order of operations here, that's 5. If you put a 2 in, you get 7. Put 3 in for x, you get 9 for y. Okay, you build your table that way. And then, of course, that gives you your domain, which is 1, 2, 3, 4, the numbers you picked, the inputs, and the range of 5, 7, 9, and 11 in set notation with squiggles, braces. All right, so got it? So if, again, like I said, if they do not give values for you to use in X, just use 1, 2, 3, and 4. Later on in chapter 9, when we move to functions, we'll use what we call the Fab 5, which is -2, -1, 0, 1, and 2. And more on that later in the year. All right, for now, chapter 1, we're just kind of getting this language of algebra stuff down. So here's the got it. Jenna picked the game card. Okay, what's my rule? Triple the number and subtract 1. Okay, so make a table for 4 different domain values, write an expression, okay, or a rule, and then state the domain and the range. So I've given you blanks here for each of these things. We'll start with what's the rule. I think that's really the first place to go. Okay, and again, if you wrote this as you can write as an expression or an equation. We'll typically write this always as an equation. In real world problems, you're going to use an equation, which means the one side of the equation is going to be whatever your output variable is equals. In this case, it's going to be y equals because there's no real world piece to this. So we'll use x and y for our input and output variables. So triple the number and subtract 1 means to go 3 times x and then -1. So there is the rule. This is the rule written as an equation, not as an expression. Okay. Now we'll make a table. So we start the table with x values, and we're going to choose them since they didn't give them to us in the problem. So we'll use 1, 2, 3, and 4. Simple enough. We can make this middle column in our table that shows what's going to happen to the x value. Okay. When these get more complicated, it's helpful to put this in there so that you can kind of keep your work straight. Okay. So substitute in x into the 3x minus 1 expression. right? And then what is your output value going to be? 3 minus 1 is 2, 6 minus 1 is 5, 9 minus 1 is 8, and 12 minus 1 is 11. So there's my table of values. Now I have the X and the Y values that go together for this rule. And finally, they ask you to state the domain and the range. Well, the domain, since you picked these numbers, the domain is 1, 2, 3, and 4. And the range, the output values that go with those inputs, 2, 5, 8, and 11. Okay, so that's the first kind of discussion here. There's really nothing new here. Just using the rule and then coming up with the X and picking the X values and coming up with the Y values for the rule. That's kind of the new thing here. All right, so now let's go to the next piece here, which is representing these relations in 4 different ways, okay? So again, you can use words, you can use an equation, a table, and a graph. Now you could add to this the 5th way, which is as a set of ordered pairs, but you very, very rarely see them done that way because normally you're going to write your set of ordered pairs in a table like this. So it's really 4 ways: words, equations, table, and graph. Okay, so they show you the 4 different ways here for an example of distance equals 60 miles per hour times the number of hours. Okay, this is for something that's traveling at 60 miles per hour. So that's the words description of what we're looking at. Okay, the distance and the hours are the 2 variables. Okay, so then they write an equation. Why is there a Mr. Yuck here? Because they wrote an equation with 2 variables in it and they did not define the variables. In any real world situation, you are going to use letters to represent these changing quantities. If you're going to pick variables, you have to say what those variables represent. It is the first part. Before you write this equation, you have to say what the variables represent. You have to define the variables. So what they should have here, as I pointed out, is that D equals distance in miles and T equals time in hours. And you must include the units. You can't just say D equals distance and time equals T equals time. Because what are the units? Is it distance in kilometers or light years or millimeters? Okay, you have to say what the units are when there are units associated with these changing quantities. Okay, so the book messed up here. They fixed it in the next example, but in this one they messed up. Okay, in the table, same thing. You should be labeling what the columns are with units, so time in hours and distance in miles. The time is the independent input variable. Okay, those are your X variables because you're choosing amounts of time and figuring out how much distance there is. Now you could flip this around and do the problem the other way if they gave you more information about what you were really trying to use it for. But since they wrote the equation over here, D equals 60T, then the time is the input because that's the variable that's getting operations done to it, right? So that's your input variable. So they pick 1, 2, 3, and 4, like we said. If they don't give you other reasons to pick other numbers, that's a good start. And then calculate the distance for each one, which is 60 times the number of hours. That gives you your table. And then once you have your table of ordered pairs, then you can make a graph. Of course, making the graph with the normal requirements for a properly labeled graph. Okay, the title here there is no title. I should have Mr. Yuck that also. So distance at 60 mph, I'll call this title. And that's, again, should be a little bit of Mr. Yuck there too. Every real world graph needs a title, okay? Real world graph needs a title. So I'll just do that. Fix that guy, make the inside white. Just to block there. Okay, there it is. I really shouldn't block because that is the graph method. So there's your title. Okay. Labels on the X and Y axes, scales that match up with what numbers you need to put in there. Okay. So graph. All right. So there's your 4 ways. Let's look at an example. So the navigation message from a satellite to a GPS in an airplane. Okay. That updates navigation every 12 minutes. This is an old book. Okay, because it updates a lot faster than that now. All right, so use an equation to find, now they're asking you, find the number of messages that are sent in any number of minutes. Okay, so find the messages, that's what you're going to calculate, and any number of minutes means that's your input variable. Okay, so the minutes is going to be your X, your input, and the number of messages is going to be the Y. So here they did do the correct thing. Here they defined the variables. Let T represent the time and N represent the number of messages. The only mistake here is that when you define this variable, you don't just say T equals time, you say T equals time in minutes. Okay, or you could have used M for minutes, but then you might get confused with M for minutes and M for messages. Right? So pick your variables. That's not wrong. It's just possibly confusing, and we want to try to avoid that. Okay, so we really should have defined it as T equals time in minutes, and N, they used N, equals number of messages. They use the hashtag, the number sign for, instead of writing out the word number. I do that a lot. Okay, so that's really what your variable definition should be. Okay, T equals time in minute. And the only problem with what they have there, well, you don't have to write it out in a big sentence like that, but they didn't put minutes in the time part right here. Okay, why did I draw the Mr. Yuck here? Because they used an elementary school division symbol for their algebraic equation. Okay, so when you're going to start doing algebra stuff like this with variables and equations, we're not going to use elementary school division symbols. We're going to use the way all your future math classes are going to show division. It should have been written like this: N equals T divided by 12. Right? This means T divided by 12, written as a fraction. Okay, so that's what that Mr. Yuck is for here and here. No elementary school division symbols, please. Okay, you can use a slash if you're typing, right, on a word processor or a Google Doc or something like that, and it's hard to write fractions there. You can write T/12 if you want to. That would be fine too, just as long as there's only one thing on the top and the bottom. If there's multiple things and you have to write a fraction, you put them in parentheses to group the top and the bottom of the fraction. You can do that. All right, so there's our equation, because it's every 12 minutes they send the messages. So it's the number of minutes divided by 12 is going to give you the number of messages. Okay. Now they say make a table, okay, to find the number of messages, and they're specifying some input values for you. They're giving you the domain. Okay. These are the number of minutes we want to look at. Okay. So 2 hours, 3 hours, 4 hours, and 5 hours, basically, right? So then you calculate what the number of messages is in 120 minutes. Okay, so then you get 120 divided by 12, okay, like that. This middle column here is optional normally, especially if it's an easy function like this, like you can do the math in your head, basically. You don't need to write this middle column in here. Some people should always write it in there, okay? But I wouldn't grade if you had this in your table or not. If I give you the space for it in something, then you should fill it in. But if there's no space for it, or you're making your own table, you can just list the X and the Y results, unless it's a very complicated equation, okay? Once you have your table, then you have X and Y values that go together, T and N, right? Your input and output values that go together. And so then you can graph them, okay? So set up your graph again. Title, which they have a title on this one, so the book very inconsistent with their title. No Mr. Yuck for the graph this time, because they have a title, GPS messages. They label both axes. They decided to use 50 on the x-axis because it has to go all the way up to 300, okay? And the y values that go with it go up to 25, so they did 5 for every line. Very good scales here, okay? Easy to read, easy to use, and then they graphed their lines. 120 minutes, 10 messages, 180 minutes, 15 messages, okay? Graph your 4 points. Now they could, okay, and we'll talk more about this when we get into chapter 9 and talk about functions more clearly. They could draw a line through these, okay, and an arrow, right? Because this, to show the trend of what's going to happen there, okay? At this point, I would not take off points for not drawing a line or with an arrow, but later on in the year, I will. Kind of like you start in 7th grade, and then later on in the year, you're doing 8th grade math, because that's what Accelerated Math 7 is. And so when we get into the 8th grade math, then we start adding some of these requirements later on in the year. All right, so here's one for you to do. Okay, got it. Okay, now you should have a separate piece of paper. You might have printed it out. I provided this notes page for you. so that you can do this graph. Okay. So this one talks about the speed of sound. Sound travels at 1,088 feet per second at 32 degrees in dry air at sea level. Right. Obviously the change in humidity and temperature and altitude changes the density of air, so that changes the speed of sound. So this is the speed of sound at 32 degrees, dry, zero humidity at sea level. All right. So write an equation to find the distance for any number of seconds. So again, they're telling you what your input and output variables are. Make a table to find the distance it travels in 0, 1, 2, and 3 seconds. So they're giving you your input values to use, and then graph. All right, so you have all 4 pieces to do here. First step, as I've spelled out for you, define the variables for this situation, the input and output variables. You can always use X and Y if you want to, okay? Or use letters that represent the things that you are, that you're working with, okay? What did I choose to do here? I said S for seconds and F for feet. If you said time, then you have to make sure you say seconds in parentheses when you define the variable. If you said distance, then you have to make sure to say feet in parentheses. You have to have seconds and feet in your definitions, okay? All right, what's the rule? It travels 1,088 feet every second. So the distance traveled, F, the number of feet, is 1,088 times S. 1,088 feet times the number of seconds. Okay, there's my function rule, or my rule or equation, right? Now I can write a table. I'm going to label the table seconds and feet. One second, 1,088 feet. Oh man, I messed up. They even told me to put 0 in here. See, they're inconsistent. So let me fix my table. Okay, since they gave me values to use, at 0 seconds, obviously, it's going to travel 0 feet. That's an easy one. Later on, when we do functions, we'll always use 0 as an input, always. You'll see why it's important later on in the year, okay? So 0 seconds, 0 feet, 1 second, 1,088, 2 seconds, 2 times 1,088, 3 seconds, 3 times 1,088, okay? So there's my table. Notice I didn't write any lines here. You don't have to write lines in your table. You can if you want to. I think I might have given you lines in my template there. All right, now make a properly labeled graph. I'm reminding you of the requirements for real-world graphs over here. A title, the labels on both axes, good scales, okay? So here is my completed graph. The title, seconds on the x-axis, feet on the y-axis, each block worth the same amount of things, right? So evenly spaced scale, labeled properly, and graph the points. So 1 second, 1,088 feet, 2 seconds, 2,176 feet. And obviously we're just estimating in between here. They don't have to be exact. I connected them with a line, put an arrow through there for later on. And that's what your graph should look like, okay? So this shows the 4 representations of this relationship. Words, that was given in the problem, okay? A rule, an equation, which you made up, a table of values, which you made up, and a graph, okay? So you know the 4 ways to represent a function, okay? So again, in summary here, words, that's the sentences that describe what's happening. Right, so sound travels 1,088 feet every second. That's words. The rule, output variable equals something that happens to the input variable. Okay. The table of values, or your set of ordered pairs, is your numerical representation of the relation. And then finally is a graph. And I use the word function in here because later on we're going to talk about functions. I really, for this, since we haven't talked about what functions are, I'll change this to relation, okay? We will talk about the difference between functions and relations in chapter 9, okay? So it gives a visual picture of the relation. That's the graph, okay? And then again, in sort of pictures, you have words. This is a separate example. This is one that's used in the 8th grade textbook. Each customer receives a coupon for $5 off. Define your variables, input and output variables, and write a rule or an equation. Right? This is for the total amount of the coupons. The total value of the coupons is 5 times the number of customers. Make your table and make your graph. Okay? The 4 representations or 4 views of a relation.